Well, good afternoon, everyone. Let's get started. And super excited to be here. And thank you all for coming to a 3 p.m. session. I hope you've all got enough caffeine, and we'll try our best to make sure that you don't fall asleep. My name's Ray. I'm a product manager. I lead product management for the AWS Robotics services. And today I'm very pleased to have Ben Wilkinson from Woodside Energy. Ben leads the intelligent systems at Woodside Energy. So today he's going to share some of the digital transformations with robotics capabilities at Woodside Energy. So for today's session, I'll first spend some time to share some of the trends we've observed in the robotics industry and some of these applications across different industry segments. Then I'll talk a little bit about Amazon, not just AWS, as a company, how we've used robotics capabilities in our business and company, and what are the lessons we've learned from these applications. And then I'll talk a bit about cloud. We're at an AWS conference, right? Like what role we think the cloud can provide to help advance the innovations in robotics. And then I'll invite Ben to come on stage and share with you guys how Woodside Energy is leveraging robotics in their business today. And if we do have some time left, I've prepared a few questions that I want to ask Ben, so we'll come back on stage and do a little bit of a Q&A at that time. So before I get started, I want to have, if I can, have a quick show of hands. How many of you guys are from companies that build robots? Quite a few. How many of you guys are from companies who use robotics capabilities in your business today? Quite a few. And for the rest, I'm assuming you're looking to leverage robotics capabilities in the future in your business. So we have a quite good mix of different audiences. I think we have a little bit of content for every single one of you guys here today. So before I get started, you might be asking, like, what is a robot? How do you define robot? Because robot is such a generic term that might mean different things for different people. So for us, we broadly define a robot as an autonomous machine that is capable of sensing its surrounding environments and making decisions through computation, then lastly, taking actions in the physical world. And with that definition, you can think of a robotic vacuum cleaner as a robot, a flying drone as a robot, a mechanical arm as a robot as well. And for a lot of the industrial applications, we're really seeing these three types of distinctive robots being widely used with increasing demand. And these are drones very predominantly used in industries like agriculture, oil and gas manufacturing, construction. Robotic arm, classic usage on manufacturing lines, assembly lines. And ground mobility robot, which we've seen increased usage across different industries, particularly in spaces like fulfillment, logistics. And now on this picture, it's an example of Amazon's latest robotic announcement we had called Amazon Scout, which is the autonomous last mile delivery robot that can send packages to people's home. And as I mentioned, out of these three distinctive robotic categories, really the ground mobile robot is the category where we're seeing a tremendous interest and huge uptick across different industry segments. This is the report from one of the analysts, and it's data from 2018. There's roughly 130,000 ground mobility robots deployed in manufacturing segment and another 56,000 in other segments, with a pretty fascinating growth rate of 333% year-over-year growth rate in manufacturing segment and close to 800% growth rate in the other segments. So it's predicted that in the next 2 to 3 years, the number of ground mobility robots used across different industry segments is going to be tenfolded. So pretty amazing growth rate over there. Some of the predictions from that same analyst saying, like, by 2023, it's estimated that mobile robots will be emerging as a standard for a lot of logistics and fulfillment processes. And by 2030, 70% of these mobile robots will be able to handle the operations autonomously without any human intervention. And really, I think we're seeing a lot of these growth of adoption of robotic technologies in different industry segments is by a few different forces. The first one is the pull of the economics. With the ever-increasing labor costs across the globe, across different labor markets, and also a decrease in the cost of a robotic device, along with increased capability, If you look at a common LiDAR sensor that probably would cost about $75,000 10 years ago, today the exact same LiDAR sensor with a little bit of enhanced capability costs just about $1,000. So a lot of innovation and cost reduction in hardware has caused robotics devices to be much economically efficient than they used to be. And it's not just about the cost, but also in a lot of labor markets, for example, like Japan with ever-increasing aging population, really there's a shortage of labor supply. So in a lot of the cases, going through this transformation with robotic automation is a necessity rather than a choice for a lot of the labor markets. And it's not just because of the economics. This is the result of a survey that a marketing company sent over to over 550 enterprise companies, asking them what's their main motivation to adopt automation or robotics capabilities in their business. You can look at the top 3 cited reasons are really to improve the productivity, efficiency, improve the quality of the service and operational capacity. It's not too much about cost reduction, but really these type of innovation give the company the ability to provide differentiated service and quality along with the pace of capacity expansion. And at Amazon, as I kind of mentioned, we've been using robotics technologies in our fulfillment centers for many years. And if you look at what we've been doing, it's really just the scratch of the surface. So if you look at the entire logistics and fulfillment chains, there are many different processes and tasks that can leverage robotics technology, but today we're only doing a tiny portion of that. If you look at processes like cross-dock, shipping, receiving, unit load moves, replenishment, all these different areas can use a lot of automation and technology, and today we're only doing a little bit of that. And if you look at these different robotics devices and machines like forklifts, tuggers, it's pretty amazing that only 2% of these devices are automated today to some extent. Most of them still require a lot of manual intervention and operation to function properly. So this kind of what we've been seeing is in the past, a lot of the operations in logistics and fulfillment center are fairly labor intensive. And today what's happening is you're seeing a lot of the robotic devices start to entering these fulfillment centers, logistics chains to work alongside humans to have these differentiated tasks between humans and robots. And in the future, we might have further automation where we leave all the dangerous, tedious, repetitive tasks to these robotic devices where human laborers can be freed up to more value-added and higher value tasks. So really in summary, we are seeing an ever-increasing adoption rate for robotics technologies across different industry segments, and particularly ground mobility robots in areas like manufacturing line for material handling in logistics and fulfillment. And we're seeing 3 forces pulling this wave of innovation and growth in these robotic technologies. One is the economics of these technologies and devices. Second one is to improve the workers' productivity, offer better customer experience, and increase operational capacity. Number 3 is a consumer demand. A classic example will be Amazon. As you all know that we try hard to be able to ship the product to our customers faster and faster. We have 2-day shipping now, we're reducing the time to 1-day shipping, and a lot of that is relying on efficiency in the supply chain and relying on these robotic innovations and technologies. So that's some of the general trend I think we've observed across the different segments and who's using what type of robots. And I want to share a little bit about some of the lessons we've learned how Amazon has been using these robotics capabilities in our fulfillment centers. And you all know that on the right-hand side, these orange Kiva robots that's manufactured by Amazon using our fulfillment centers to move these rack of products around. Really, the purpose of these devices is so that we can increase our productivity, we can increase our capacity, we can increase the throughput of packages coming in and coming out of our fulfillment centers. And the ultimate goal is to be able to ship the product into our customers as fast as possible and as cost-effective as possible. If you kind of take a bird's eye view of how these things operate in our fulfillment centers, these green dots here are racks of products where we put different type of products into the rack, and these products are not really organized by the type. For example, books don't always being placed alongside of other books. We place these different products in such a way to maximize shelf space. So you'll see a mix of products that is entirely not related on the same rack placement. And these orange dots are the Kiva robots. So they can pick up the entire rack of products and move around the fulfillment center. And on the left-hand side, these are what we call stations. And we have these human workers working at these stations. So what happens is when you place an order on Amazon, it goes through multiple systems, and eventually your order gets placed onto one of these Kiva robots. It'll figure out where the item that you just ordered is on any of these possible shelf spaces. It's going to move over to one of these racks, pick it up, and deliver that entire rack into the station on the left-hand side. Then the human worker will just pick that item, put that in a box alongside with all the other items you've picked, you've ordered. So if you look at this entire process, an interesting thing that you can see is previously, without these type of automation, what these warehouse workers need to do is they literally need to walk alongside these aisles and find the right items and pick the items from that particular rack of products. And these are not tiny fulfillment centers. These are huge warehouses, which means for a worker outside of an 8-hour working day, the vast majority of the time they've spent is basically walking alongside these aisles in a warehouse. Kiva fundamentally changes that model in a sense that the workers no longer need to go to the product. The product actually comes to the workers. So for these workers now, vast majority of their time on a workday focuses on the task of picking the item outside of the rack, which is really something that requires a very specialized skill sets that only humans has. For example, the dexterity of the human hands to be able to pick up different type of items, dealing with ambiguity, being able to make a judgment call when it's a wrong item or when the item is not in the right stack. So these are really, number one, is changes the value-added work the worker is doing. Really now the time of these workers are focusing on the high-value work that can only be done by a human and leave all the tedious and repetitive tasks to the Kiva robot. Number two, which is a super important part, is data. And because the fact now all these items are being moved by the Kiva robot, we can collect these data to track exactly what items are at what stack and what's the distance and the time has been used by the Kiva robot. And the objective in the end is fairly simple. You want to minimize the travel time for the Kiva robot so that it'll be more efficient and have a higher throughput. And that has a fairly complex algorithm to figure out what type of items should be placed on what type of rack and where we should place a particular type of rack. For example, whenever it gets close to the holiday season, you probably want to put some of these gifts, these popular categories where people typically shop around holiday seasons, closer to the workstation. And when summer comes, you probably want to move some of these summer items people like to purchase closer to the station. So we keep tracking all these different purchasing trends along with how much distance the Kiva robot has traveled to keep optimizing the way we place items onto these storage rack and also where we put these rack. So data is super important in a sense with these type of robotic devices and digital transformation that you can continue to optimize your workflow and get more efficiency, which we couldn't quite do previously when everything is operated manually. You just don't have that data to continue with the optimization. This is just a kind of image of what I just described. You can see these Kiva robot, they take up that entire rack of products, they move towards a station, and in this case, a human worker will basically pick the items and put that in a box before we ship that to the customers. So here are like a few lessons I think we've learned throughout the implementation phase of these innovations in our fulfillment centers. Number one is you want to pick a task level execution to be automated and leverage a robotic device. And you want such task to be able to complement what a human worker is good at. So typically you want to pick the items that's repetitive, that's dangerous, that's tedious, and that's suitable for a robotic device to handle. Number two, again, like focusing on automating these tedious works for the robotic devices so that the human workers can focus their time on high value added tasks that's uniquely can only be done by a human being. Again, these are the type of tasks that require human judgment, require ability to dealing with ambiguity require dexterity, which a robotic device really can't do today. And the third one, as I mentioned, data is super critical. As you kind of automate a lot of these processes, combine that with data collection, that'll buy you a lot of efficiency, leave a lot of information that you can leverage for further optimization of the processing. And the fourth one, which is pretty interesting, is once you deploy a automation or robotic solutions, it's actually, they're fairly sensitive to any changes of the surrounding environments, which means you gotta have to start with some fairly focused workflow or focused area and double down and keep expanding on that particular cases and really think through, because we've made these mistakes over time where we kind of try to automate a lot of different things as a starting point, but later on we figured actually some of these won't make sense. But anytime when you make a change for logistics and supply chain, it's a little bit like a butterfly effect. You change a little bit, it'll impact a lot of the upstream and downstream workflows of the entire logistics chain. So making changes aren't very easy. Pick a right spot, experiment, and grow from there. And lastly, these type of integrations require hardware technology, software technology, and integration capabilities. So it's super critical to work with different partners across the robotics industry to be able to implement and scale these type of implementations. So this is some of the trends we've observed and how Amazon has been leveraging these capabilities, what we've learned. And next, I want to talk about cloud, which is what I'm passionate about. Last year at reInvent, we announced a first robotics service at AWS called AWS Robomaker. And that service was really built for companies and developers who build robots, not necessarily for companies who use the robots. But I think it'll be super interesting for me to share that how we, AWS Robomaker, we're helping these robotic manufacturers, these robotic builders, to increase their productivity, increase their pace of innovation, and give them more capability so that as the end user like you guys can see the possibility of what a robotic device can do in the future. And I want to do that through sharing some of the use cases, some of the customers we are having today. Not all of them are doing for industrial applications, but nevertheless, I think if you see how they're using these Robomaker capabilities, you'll be able to see how we can also help these industrial robotic manufacturers to increase their pace of innovation. So, Robomaker's got three independent but also integrated capabilities. The first one is what we call cloud extension for robots. As you know, at AWS, we have a wide range of services capable of doing different type of things. For example, monitoring through metric data, log analysis. Now we have Polylex, you can do voice interaction. We've got video streaming capabilities, image, video recognition capabilities. All these type of services and capabilities are highly relevant for robotic devices. What we did over there is we built a software packages that's suitable for the open source robotic operating system, which is a fairly common software used on a lot of robotic devices, to make it easy for the developers to connect their physical robot edge devices with these cloud services so that we can bring all these type of powerful functionalities onto the robotic device. Second capability is simulation. Simulation is a fairly important innovation in robotics where a developer can test in robotic functionalities in a 3D virtual environment versus in the physical world, which really brings a lot of agility and test case coverage for these developers, which I will share a few use cases. You'll see how they're using it. And lastly, is fleet management. We provide capabilities to register physical robots with the cloud and create connectivity. You can organize these different robotic devices by fleet, and we provide secure capabilities for developers and robotic companies to push software updates from the cloud over to their robotic devices. Okay, now I want to share with you guys three customer stories who's been using Robomaker capabilities to help them move faster. Again, these are not necessarily industrial robotic applications or devices, but nevertheless, you can see from how they are using these capabilities, a lot of these patterns are applicable to industrial robots and applications. This is one of my favorite customer story. It's a device called Leah. They're manufactured by a startup based in Europe called Robotic System. Leah is a autonomous robotic walker that's capable of navigating indoors. It helps people with disabilities to regain mobility. Basically, instead of moving towards the walker can come to you whenever needed, and once you're done, you can send the walker away. Leah comes with 72 sensors to be able to do autonomous navigation, and also with a bunch of built-in security and safety features. And in order to keep the cost structure low and make sure the device is accessible to the broadest customers and users possible, it comes with fairly low-end CPU power and memory resource on board. When we first met the Robotic System team at a conference that we had a few years back, they really heard a lot of demand from their customers want to have, for example, voice interactions with the Leah. So before they had that capability, the user needs to push a physical button on a physical device to have Leah come over to the patient so that they can use it. But these end users, customers, they want to have these voice interaction capabilities to talk to Leah and use voice command to control Leah. They want to have real-time monitoring capabilities so that the patient's families can see what's going on and make sure the patient is safe at home. They also want to have live video streaming capability for the similar manner. Well, but they faced a lot of the challenges because it was a startup company, it was a fairly small team. They didn't have enough resource, and the team didn't have all the expertise in these different technological areas, like natural language processing. And not to say that Leah's got a fairly limited on-device compute power that's not capable of doing these type of voice processing computation. And that's where Robomaker's cloud extension came to help. And here's how they did it. The Leah device is running on a ROS framework. They leverage the cloud extensions we provided. So from the Leah device, they're streaming these video data, these metric data, these voice data over to the AWS cloud and do all these heavy computation in the cloud using these AI monitoring and video streaming services we provide at AWS. And then they just stream the result back to the Leah device to provide these functionalities to their end customers. The results are really pretty amazing. The team was able to build voice interaction and live streaming and live monitoring capabilities into Leah within hours and days. And that's all based on the fact that it was a fairly small team without any prior experience in any of these technological areas. And this is one of the quote from Gabriel Lopez, and he's one of the founding members of Robotic System. He says, it was a revelation seeing how easily cloud connectivity can be created or achieved through AWS Robomaker. We immediately realized that we could use Robomaker to take the next release of Leah to a higher level. So it's a pretty exciting quote, and you can see by leveraging a lot of these innovations happening in the cloud and through network connectivity, we can bring a lot of these functionalities onto the edge devices and including robots. Next, I want to talk a little bit about simulation. As I mentioned, simulation is a core technology and innovation in robotics for people to test their robotic functionalities to train machine learning models. It's so much more efficient than doing that in the real world. And Robomaker provides a simulation capability as a fully managed and serverless service. So you don't need any infrastructure or anything. You just bring your robotic applications. We will run the simulations, take care of the scalability, availability, and performance of it. And that's the next user story I want to share with iRobot, how they're using simulation. I'll just briefly go through how iRobot is using simulation for regression testing, one of the top use cases we've observed. And I believe we have a session tomorrow morning where our team and iRobot will get on stage, do a deep dive on this particular use case and how they did it. So if you're interested, you should check out that session tomorrow morning. So everybody loves their Roomba. I own a Roomba. I'm a big fan of it. That saves me 3 hours a week where I used to do the cleaning work and vacuum work for my home. And you can imagine, for those of you who own a Roomba vacuum cleaner, the device needs to operate in a wide variety of different homes with different floor layouts, with different floor materials. Some might have kids and pets running around. Some might have hostile owners who might kidnap their robot. And kidnap robot is one of the terms that iRobot uses to describe a scenario where you pick up your device in the middle of the cleaning mission and you move it somewhere else and drop it, which will cause the robot to lose localization. Basically, it'll get lost and couldn't figure out how to go back home. And I can see some of you guys going to try that once you go back to your home after reinvent. But how does the developers at iRobot make sure that the software applications, the navigation algorithms is able to handle all these different situations and scenarios? You need to run a lot of the tests. And you can't, I mean, it's extremely costly for you to do that in the physical world, if not impossible, because you can't quite put your Roomba in 5,000 different rooms and running these different types of scenarios and tests and over again. That's problem number one. Problem number two is when you run these tests in the physical world, typically that happens sequentially with your development process, meaning you'll first have your developers write the functionality. Once everything's done, then typically a QA process kicks in, which means when you discover any issues or bugs, that's very late in the development life cycle. That's right before your product release, which means if there's any issue that's being found during that QA phase, it'll probably cause some interruption, disruption to the release cycle. And that's where simulation can come to help. So instead of doing these type of testing in the physical world, you do that in the virtual world. You model a home, and you can introduce different floor layouts, different furnitures, different lighting conditions, different floor materials, different moving objects inside these homes. And the beauty of simulation is that you don't do that in just one room. You can do that in tens, hundreds, and even thousands of homes. And you can do these type of testing in parallel. Again, like if you're interested in how iRobot is doing that using AWS Robomaker along with a few other AWS services, there's a talk tomorrow morning. You should go check it out. And the results are pretty amazing. So today, iRobot has built simulation into their continuous integration flow, meaning every time when a developer checks in their code update to the repository of the Roomba application, a number of tests will be kicked off and to run in simulations. And before they release the code onto the physical Roomba device, they run a number of other tests again. And as you can see, number one, you're able to achieve much faster testing cycle to do that in the virtual simulation world compared to the physical test in the physical world. And number two, because it's part of your CI integration process, you are basically testing as you develop. So a lot of the issues and bugs can be caught very early on in the stage so that there's a lot more predictability in your release cycle without too much disruption later on in the development life cycle. Next, I want to talk about Deep Racer. How many of you guys know Deep Racer or have tried Deep Racer? Yeah, thank you. It's a fantastic project, and it's such an exciting thing that we announced last year at reInvent. For those of you who have tried Deep Racer, you've already been using AWS Robomaker's simulation capability. So the way Deep Racer works is it's using a ML technology called reinforcement learning. Basically, the way you train a reinforcement learning model is keep doing through error and trial. Basically, you have a reward function. The car just keeps trying. Every time it drives outside of a track, it's get a minus on the rewarding function. Every time it keeps driving inside the track, it's got a plus. And you just keep trying this. You just keep trying this for tens of thousands of times until the algorithm pick up where it'll always drive inside the track. And if you think about it, how could you possibly run tens of thousands of these different types of trials in the physical world? It's just impossible. And the only way to do that is through simulation. So you run these type of trials inside a simulator and train the model running in AWS Amazon SageMaker. And the beauty of simulation for machine learning model training is, number one, for each of these simulators that you see here, they can run much faster than real time, which means for an hour of training simulation might be the equivalent of 5-10 hours of training in the physical world because they can go faster than real time. Number two, if you host your model in Amazon SageMaker, you can actually initiate multiple simulations in parallel. So you can actually have 5, 6, 10, 20, 30 different simulators to train the same model inside SageMaker concurrently. Again, that significantly speed up the training time so that you can get the results much, much faster. And this video, just, it's a pretty successful transfer from simulation to the physical world. The cars learn how to drive inside a track after many, many different times of trial, fail, and error, and correction inside the simulator. So just to summarize, with these different capabilities, we're providing Robomaker to help these robotic device manufacturers and companies to build more innovative robotic devices. Number one is we think the intelligent capabilities, the powerful services we have inside the cloud through connectivity can really augment what an edge device, including robots, can do. Number two is we think simulation is a key capability that will ensure the successful test coverage and increase the quality and robustness of robotic devices. Number three, we see in the future a lot of the advanced and complex robotic functionalities will not be programmed by a developer, but rather being trained through machine learning model. Again, we think simulation is a key capability to enable a lot of the training for imitation learning and reinforcement learning, and deep race is just one of the examples. And fourth, we have a bunch of developer toolings like Cloud IDE, code build, code pipeline, over-the-air software updates. We think a wide range of toolings we provide in the cloud will really help accelerate and make it easier for robotics developers to develop their applications and focus on the functionality of the device. With that, I would like to hand it over to Ben. He's going to share with you guys how Woodside Energy has been using robotics capabilities along with other technologies to innovate with their business. Ben? Thank you.
Oh, thanks, Ray. Really happy to be here. So just to give you a bit of context about Woodside. Woodside is the pioneer of the LNG industry in Australia. We operate about 6% of the global LNG supply. To give you some context, that plant you see there is one of 6 LNG trains we operate, and that's about 1 kilometre by 1 kilometre in that part of the plant you can see there, and that doesn't cover the offshore facilities. Innovations in our DNA, be it the first LNG facility in the Southern Hemisphere, the largest not normally crewed offshore facility, or our work in hydrogen. But today I'd like to talk to you about something closer to my heart, which is the intelligent asset. The goal is simple. We want to make things work harder so that people can work smarter. We believe that we can provide greater than human awareness, which will allow people not to have to enter the field just to acquire new data. We believe if we can achieve that, we're going to be able to eliminate some of the low-value tasks and free our people up to focus on higher-value activities. We also know this is important to do it in an engaging way. We need to provide a good user experience, or we're not going to get the uptake within our organisation. We operate in a framework of sense, insight, and action. In sense, this is really about how do we know everything we want to know about these complex assets. Traditional instrumentation does exist, but it's expensive to scale. We're already streaming hundreds of thousands of data points into AWS Cloud today. So in this area, we're focused on IoT-style sensors and surveillance robotics. Insight. Look, we all know that gathering data doesn't add any value. You need to actually drive insights from it. So in this area, we're really focused on advanced analytics and machine learning. But probably more importantly, we're also really focused on advanced user experiences. So we're looking at augmented reality, virtual reality, and providing a digital workspace that's a digital twin by some people's terms. The reason we do that is our people still make most of our key decisions. Then we move to action. Again, coming up with insights doesn't actually add value. You need to turn those insights into outcomes, so we need actions. At the simple end for us, this is about system integration, providing the right data to the right people at the right time so they can act on it there. At the other far end, it's about being able to task a robot to go do a surveillance activity autonomously, or to, in the future, task that robot to go do a manipulation task in the field. I thought I'd share with you 4 areas that we've been working on. The first is the surveillance robotics and our site trials, then task autonomy with manipulation, the development of IoT sensors, and then how do we bring it all together in our digital twin. Surveillance robotics. There are 2 real areas we care about for surveillance robotics. The first is no matter how many sensors we put in a site, there is always going to be that situation where it doesn't cover what you want to know. A good example would be a camera may pick up there's a puddle of water on the floor, but we can't see where it's dripping from. What we do is how do we send a surveillance robotic to autonomously go gather more data so you know where it's coming from. The second area is the cost of some sensors. Things like high-quality LiDAR and thermal cameras are still expensive. So being able to put these on a mobile platform that we can deliver to wherever we need them allows us to scale through this whole facility. The video you're seeing right now is actually a gas turbine enclosure. It's a very hot, very noisy environment that we don't send people into while we're operating. But in this case, we can teleoperate a robot to see if an inspection would be possible while the facility's running. Sometimes it's the little things you learn from site trials. The thing we learned here is don't 3D print your brackets out of cheap materials and then put them in a hot room. We found the cameras drooped a little bit, nothing melted, but we learned to use better quality plastics. It was a successful site trial, and that was one of our earlier ones. Autonomous navigation is important for us because we want highly reproducible, continuous surveillance of our plant. Here's an example where the robot's navigating down what's called a fin fan deck. Think of an LNG facility as a giant fridge that's trying to chill things down to minus 162 degrees Celsius. These fans eject the heat out of the top. By the robot navigating its way down this deck and inspecting things with a thermal camera, we get a good feeling for what's the condition of those bits of equipment. And here you can see the complexity of the environments we need to navigate through. They're not very textured and they're highly repetitious. They're both bad things for SLAM. The next one's a demonstration we did between Perth in Australia and Beijing in China. This was part of the LNG 19 conference. So what we've got here is a pump's had a problem and we've detected that anomaly with one of our IoT sensors. The operator has now been asked to shut the pump down. For whatever reason, that hasn't worked. What are they going to do? Dispatch a robot, of course. It's probably just worth noting here, everything this robot doing is fully autonomous. It is not being teleoperated or guided in any way. The first thing this robot do will locate itself and find the valves that it needs to operate on. When it gets there, the first task it needs to do is actually shut the pump down. You'll probably notice the little April tag sitting there above it. The reason we used that was to improve the perception during this demo because we repeated this many times during a day and we didn't want it to fail when we were doing a live demo. But perception is one of those areas that still needs a bit of work in robotics, and that's one of the areas we focus on. If you're like me, probably the second thing you really notice about these robotic demonstrations, they're not necessarily the fastest things at what they do. A robot takes a bit of time sometimes to complete its task. But you need to remember, this could be on an offshore facility that's 100 kilometres offshore and thousands of kilometres from a major city. So it taking time may have just saved us having to fly a helicopter of people 100 kilometres offshore to go do that task. So it still is a very big time saver for us. So it's now completing the first valve being turned. We'll then have to locate the second one and turn that. The procedure is called a double block and bleed. It has to turn the 2 valves to isolate that part of the circuit. It turns a third valve, which then bleeds it. The thing I like most about this demonstration, it really shows the end-to-end integration of everything we're working on. It's got an IoT sensor that detected that anomaly, machine learning that found it, and then gave the operator the ability to actually act on that without having to be involved. And there you have it. It just finished its double block and bleed and it will return to its base. Okay, one of the other things we've been working on is trivialising the cost of data acquisition. So as I said earlier, traditional instrumentation has existed for quite a while. We use a lot of it. But the problem we find is it costs us tens of thousands of dollars per sensor by the time it's actually deployed. What we wanted was, how do we make that hundreds of dollars so that we can do this very quickly and scale across all our assets? So we set ourselves some challenges. We said this has to be really easy to do because half of the cost is actually doing the deployment itself. Then we decided that it needed to be quick and be able to be done with a mobile device. It needed to be wireless so that we didn't have to cable anything, which means it would need to be battery powered. We soon realised we didn't want to spend the rest of our life swapping batteries in tens of thousands of sensors. So we ended up spending a fair bit of time focusing on power management. We set ourselves the goal of being able to run a sensor for 10 years without having to replace its battery. The good news is we achieved it. So the sensor second in from the right was our first sensor that we deployed into the field. It's a zone 1 rated sensor that does vibration, surface temperature and ambient air temperature. It's used for condition monitoring of equipment. We learnt a lot from that, and we built the one that's now the orange one you see there. That one's basically the same, but has 2 additional ports so that you can add different types of sensors and also do multiple sensing points from one sensor. We then started to work with our operators around solving some of the other problems, and it became really apparent really quickly that visual inspections are a large part of their life. So the next sensor you can see across there is actually a low-cost camera. The reason we did that was we looked at the industry, and it was about $10,000 to $15,000 for an intrinsically safe camera to be deployed, and we wanted to do thousands of these. So we had to come up with a camera for a couple of $100 that's easy to deploy, captures audio and video, and can send it back to be processed. Great. So we've got lots of ways to acquire data, but what are we doing with it? You can see here, this is the water treatment part of our Pluto facility. We decided we need to actually prove this to our production people that we can actually add value to their jobs. So since July, we've been live with this digital twin. I'll just go back into the 3D model, which is the as-built models we use. Okay. As you notice, when you look around, equipment pops up its key details as you travel around the plant. If you look over to the other side, that will also load through the details. If we go into a pump, just to have a look more at the details, this is fusing the process data, the IoT data, and any other insights that we're deriving. You can change the time in the time slider, and all that data will reflect what you're choosing. You can look at it over a range, and if you click on, say, the image library, it will show you the images that were taken during that period of time. This is true for all the information in this model, all the equipment. So as you travel through, you'll see tanks, valves, other things that you can interact with and find out anything about it. In this case, we'll choose a simple one, and we'll look at a valve as an example. You can see the view of its state, and if we slide back, it will update to reflect the time frame we've chosen. Okay. We'll go back into our reality capture view. We get asked quite a lot, why do we use the reality captures? And the feedback from the operators was they don't want to see what the plant was designed to be, they actually want to see what it is. So what we do here is we regularly rescan the plant with a high quality LiDAR that also generates an RGB point cloud. Then we localise all this information within it. This means they can see the plant as it was last week, not as it was designed. We'll go have a look at another bit of equipment here. So we'll turn the pop-ups back on and go look at this pump. What I want to show here, that's the data you've seen before, but now we can actually go into the equipment details. And what this is showing is not only do we have the data that's available from the different sources, we also have measures and insights being derived from our data analytics. We have all the operational procedures and tasks that need to be performed. We have engineering data, and in this case, we'll show you the process diagram that relates to this pump. If you needed to add a task for that particular activity, you can add that as well. Great. So we've got lots of data, we've contextualised it, we've provided it both in time and space, but we haven't really added any value to anyone in our organisation just doing that. So one of the things we focused on was OPAM, which is our preventative maintenance tasks. So the operators can have a look at their tasks and see what's available to be done that day, click on those, and then choose a task. In this case, it will give them a description of the task, and it will show you the equipment that it relates to, and then give you the ability to close the task. If you click on the equipment, it'll take you to it. You'll see the analytics there telling you what level the oil gauge is, as well as the other information. If you needed to add any actions, you can add the actions, and they'll show here so they're available for you later when you enter the field. Another area that we're looking at is SOSO, which is starter shift observations. Every day when someone starts a shift, they need to go into the field and familiarise themselves to make sure the plant's operating as it should be. By using robotics and sensors, we can acquire enough data where we can step them through each of those points they would normally investigate and give them a good understanding. A really simple example of how this has been used. Say you're looking at an image and you're thinking, why are all these boxes sitting in my plant? You could have gone through the permit tree and tried to work it out, or you can just slide back in time and see what work is being done there. Really simple example, but shows how it works well. And this part's just showing that because all our cameras are capturing audio, we spatially locate that all, so as you walk through this plant, you can actually hear it and experience the plant as it is. The reason we do that is situational awareness is really important to our operators. They need to know what it looks like, but sounds like as well. One of the other things we've learned is those nice reality captures that we take also turn out to be great base maps for our robots. So SLAM still has challenges in these complex environments, but we're finding that actually navigating through a base map generated by those LiDARs is actually working really well. Here's an example where we're taking one of those reality captures and the robot's finding its way through waypoints, just demonstrating its ability to navigate. It'll then finish its navigation and return to the robotic outpost box and inductively charge. Those trials are going very well, and that will be deployed into that water treatment plant we showed you before, Q1 next year. Okay, so what have we learnt? The first one was the importance of stakeholder engagement. So every 2 to 3 weeks, we travel on site and work with our operators. Why? Well, we usually think we know what's a good idea, but it may not actually be what's useful to them. And every time we visit them, we always come up with new ideas and new things that will add value to them. User experience is really important. You can come up with really great ideas, but if the user doesn't feel the value from it and engage in the way it's useful, then you're not actually going to be successful. The next thing is treat all things as things. So that's kind of obvious when we talk about our sensors. Prototype one sensor, not too hard. Scale to thousands of sensors, you need to start thinking about it. You need to be able to configure, deploy, manage, and get diagnostics from them. But it's the same problem for robots. So you can build one robot in your lab, but when you want to deploy a fleet of robots, you better make sure you can configure, deploy, monitor, and do diagnostics on that robot as well. For the sensors, we use IoT Core, and we use device shadows and services like that to solve that problem. In the robotics space, we're using Robomaker, which is turning out to be very useful. The next thing we learned is really system integration. What we didn't want to do is create new silos of information. So we've made sure that everything we're working on is integrated across all our systems. And the reason for this is we want the ability to reimagine processes, not just optimise one step. And we also want to make sure all our data is available in context so that analytics can be run across all our different data sources. We don't want to create new silos. The next one was to address the cloud and edge balance. We now have the ability to generate petabytes of data per asset per year. Now, these assets are fairly remote, so you're not going to be able to stream all that consistently to the cloud. So what we do is we use edge compute to enrich the data we do want to stream, but then we also use the edge compute to do the analytics to only stream up the anomalies we care about or where we want to update a model. Just want to share, this is an emerging market, so you need to be ready to get your hands dirty and get involved in things. I'm really lucky. I work with a great team of people. It makes this achievable. We have great partners like AWS as well. But I guess the point here is you can't just go out and buy it, so you need to be ready to build it. Thank you.
This is super interesting and exciting, and since we've got a little bit more time, I do have a few questions for Ben. Can you tell us a little more about what value have you got out of deploying these super interesting technologies in your business?
So to be honest, we went live in July. I think we've got a pretty good line of sight to proving that value, and we're hitting our key metrics that we're trying to measure around field time and other areas. But I think the biggest measure of success for us has been the demand from the business, where they're pulling more technology. They want us to deploy quicker across more sites. Right. That's probably the best measure.
And second thing is, you mentioned, how do you guys manage to move these cutting-edge innovations from the lab into the production settings and run that at scale?
Yeah, so we do have a very experimental mindset where we kind of set out, this is what we want to do, let's do the least effort to prove it. But one of the things we do a little bit differently, I guess, is we plan for success. So where we were talking about using Robomaker, which we started using very early on, we knew if we succeeded, we didn't want to be stuck with a scaling problem that says, great, how do we manage these? So we always try and plan as if we will succeed, but we're willing to pull the pin on it if it's not working.
Got it. And as you kind of went through the journey of innovating in lab, moving to production, any surprises to you, other than the fact that you guys found out that plastic would melt at high temperatures?
Probably the two most surprising things, it's just been the number of ideas our operations group come up with. So we thought we were pretty good and had some good ideas, but every time we've engaged with them, they find new ways to use robotics and sensors for us. So that's probably been the biggest surprise. And the other one's been a lot of the problems that you think are going to be hard when you start out turn out not to be hard. It's just no one's bothered to put the bits together.
Right.
But the inverse is also true. Some of the things you think are going to be easy turn out to be very hard.
Yeah.
So,
Lastly, like with all that, where do you see this thing going inside Woodside Energy in the future?
Yep, we're really being asked to scale this now as quickly as we can. So the part of Pluto that we showed you before, that facility is say 1 or 2 kilometres by 1 or 2 kilometres, and that's excluding all the offshore assets that are related to it. The particular part of the asset we're working on is about 150 metres by 100 metres of equipment. So we've got a lot of work in front of us to try and scale this across all our assets, not just the one facility. So
great.
Yeah, we're really looking forward to that.
Yeah, that's super exciting. I think given that, I want to thank Ben to come over and share your story with the audience. I want to thank you guys to be here today. And we're going to be hanging around a little bit, so if you have any questions, feel free to come over. Otherwise, I hope you enjoy the rest of the conference. Thank you guys.